And action.
Okay, back to division, part 2. Okay, rationalizing the denominator, okay? You cannot have a radical in the denominator. Just like I said before, just like you can't have variables on both sides of the equal sign, this is another one of those rules. You cannot have a radical in the denominator. How you get rid of radicals in the denominator is by rationalizing them. How we do that is by multiplying, put the dot, do it now. Multiplying both the numerator and the denominator by the radical that is in the denominator. So radical 7, okay? So now we already know how to multiply radicals, so let's just multiply straight across. So radical 3 times radical 7 is radical 21. Radical 7 times radical 7 is radical 49, okay? And now we have to deal with them individually, numerator and denominator. You bring over your radical 21, and then what's the square root of 49? 7. Did we get rid of the radical that's in the denominator? Yes. Is that what we wanted? Yes, and we're done. Now, here is 2 things I want to point out to you. Number 1, look at the pattern, okay? Look at this. Radical 7 times radical 7 gave me the square root of 49. And what's the square root of 49? 7. So do you guys see the pattern? That when you multiply anything by itself, it's a perfect square, and it will give you what you originally had without the radical. Okay? Secondly, here's another question. Can this be, and students make this mistake all the time, can this be simplified any further? No. Why? Because the 21 is inside of a radical, and this is the whole number 7. Just like you can't multiply whole numbers to radicals, you can't divide whole numbers and radicals, okay? So let's take a look at example B together. I'll just do it with you, and then we're going to go over these examples without the video. Okay, so everyone write this example number 2. Oops, is it moving? There we go. It's not cooperating. Radical 7 divided by radical 8n. Okay, so we have a radical in the denominator. We cannot have a radical in the denominator, so we have to rationalize it. How do we do that? By multiplying both the numerator and the denominator by the radical that is in the denominator. Okay, so now you just multiply straight across. So radical 7 times radical 8n is radical 56n. And radical 8n times radical 8n is radical 64n squared. And then is there a perfect square in 56? Because we have to deal with the numerator and denominator individually. Is there a perfect square? And what times what gives me 56? And one of those numbers has to be a perfect square, because we know 8 times 7 is 56, and there's a perfect square in 8. So 4 times what gives me 56? Can anyone use a calculator? Divided by 56 divided by 4 gives you what?
14.
14. So we have 4 times 14 times n. Okay, so we draw the roof, and we're simplifying in the numerator. Okay, and then why do we love 64? It's a perfect square, and n squared is a perfect square, so we have 8n in the denominator. Next step, take the square root of our perfect square in there. So what's the square root of 4? 2. I'm going to write it down here. Okay, what is still left over under this roof? 14n. And what's in our denominator? 8n. Now, look here. Can anything be simplified here? Yes. Okay, we have the whole number 2 and the whole number 8. Even though this 8 is being multiplied to the variable n, that's okay. Whole numbers can be simplified. Okay, you just wouldn't be able to, like if this 2 wasn't here, you just wouldn't be able to simplify the 8 and the 14, even though they're both divisible by 2, because 14 is inside of the radical. Do you guys understand that? Okay? Now, this can be simplified, so 2 goes into itself once. And then we have 4n in the denominator. So radical 14n divided by 4, 4 divided by 4n, and you're done. I'm going to put it in this video now. No, I'm not. Okay, there you have it. Thank you. Fabulous.